I've been using the TriCetech business automation platform to try to create services of interest to practitioners in the mortgage industry. And we're aiming at a new sweet spot at the intersection of business automation, cloud-native microservices, and low-code based on model-based design, all running on industry standards. Now, all three of these things are built into DMN today. So you can, as you just saw, create executable decision models without programming using field and boxed expressions and deploy them in one click as cloud services. But to be practical, decision services need to be wrapped in a process to obtain the input data, to validate it, to transform it, and to take action on the decision result. So as you just saw, TriCetech lets non-programmers create executable bpmN by borrowing field and box expressions from DMN and deploying also as a cloud service. In the process model, the data mapping, service invocation, gateway logic all use field and boxed expressions. But real source data is not field. It's usually XML. So TriCetech automatically converts XML to field. Using these platform capabilities, we can create business automation services that are useful in mortgage, data validation and mapping, composable compliance and underwriting services as well. New standards create openings for new technology. MISMO defines a new standard XML schema for all mortgage data, and Fannie Mae and Freddie Mac soon will require the data to be delivered in this format. Fannie and Freddie have also agreed on a new standard loan origination form called ERLA for visual presentation of the loan data, such as the borrower's income, assets, and liabilities and details of the loan. For example, Fannie Mae's underwriting defines a minimum credit score based on the loan-to-value ratio, LTV, the borrower's debt-to-income ratio, DTI, and the liquid assets after closing called reserves. It's easy to represent that logic in a DMN decision table. But now suppose the lender wants to determine the maximum eligible loan amount based on the ERLA income and asset data. So here is the DRD for that. The input data now are the ERLA data in MISMO XML, the loan-to-value ratio LTV because we want to vary that, and the lender's daily best interest rate offered to the low-risk borrowers. The logic here is more complicated because as the loan amount increases, the monthly payment increases, even the interest rate increases, changing DTI, reserves, and all those key parameters. So we need a process to prepare the MISMO data for the underwriting decision. Schema validation, data completeness validation, and mapping to a more DMN-friendly format. Because MISMO XML, imported directly to field, is not DMN-friendly. At the top, you see here, is the borrower's credit score in field generated directly from MISMO. The bottom is after mapping to a more DMN-friendly format, much better. In bpmN, a decision task executes a DMN model. And boxed expressions, as you just saw, map process variables to the input data and the decision output back to process variables. Service tasks likewise invoke the data mapping and validation services, and we import the services Swagger file, link the task to its operation, and map the inputs and outputs. As with DMN, we can publish and deploy the process to the cloud in one click, specifying the authorization credentials, and then from the service library, we can test the deployed process. So testing the process service, just like a decision service, we specify the data inputs in either field or XML, and the service returns the values also in field and XML. So we've created the following artifacts. an ERLA XML form, interactive form, utility services to validate and transform the mortgage data, and modifiable business automation services in both DMN and bpmN. So let's see how this works in action. All right. My mouse works. Okay, good. Does it work? Hang on here. There it is. Okay. So here is the DMN decision model for the Fannie Mae underwriting, and it incorporates all the rules that they specified. And so the input data is the loan application form, ERLA here, and you can see if that would be approved or not approved. And we can run this. So Fannie Mae published a sample file for a Ken customer who wants to borrow $300,000 on a $340K property. And so we run this, and we see, well, Ken is ineligible because the minimum credit score is 680 to approve that, and his score is only 660. So this model incorporates all of Fannie Mae's underwriting rules, and it's a starting point, could be modified by any practitioner to apply their own underwriting rules that might discount certain classes of income like bonus and commissions or whatever. But since Ken was not eligible to borrow $300,000, we might say, well, what loan amount would he be eligible for? So we can modify the decision model, make it a little harder. So now we've got the ERLA form, the loan application form, but we're also putting the loan to value, that's the loan amount divided by the property value, as an input data, and also the current lowest interest rate offered to the lowest risk customers. And so we can try this at an LTV of 80% and a best interest rate of 40%. And well, it turns out that if Ken only borrows $272,000, which is 80% loan to value, the minimum credit score is 660, which matches Ken's credit score. So that's good. And the additional complexity, I said, when you change the loan amount, you're changing all the key parameters of that underwriting decision, the DTI, the reserves. So if you look at, say, the monthly payment, the logic here, this is what DMN calls a context. It's got two columns. Think of it as like a sub-process. In DMN, these are all local variables. These are simple field expressions. And so even though the logic is complicated, it would be understandable to any subject matter expert in a bank without programming. So it's understandable and modifiable, so they can basically compose whatever logic they want. Now, I also mentioned that the data is field here. And all these field data types, there's a lot of them, were created by importing a schema, because the source data is XML, and we need to convert it to field. So TriStatTech creates the field data types simply by importing a schema, and there's a component in TriStatTech that automatically maps XML instances to corresponding field instances at runtime. So here's the data type for the ERLA form. It's a complex structure, as you see here. So this is all field data. Now, let's see. You saw this much basically last year. So let's look at what's new. And what's new is dealing with the data, because as I mentioned, real source data is not feel. I mean, you're not going to find out-of-the-box connectors that produce feel. Maybe Denise connectors produce feel, but most of the ones are going to produce, say, XML. And you need to map that XML to feel. But as I mentioned in the Ignite, standard XML schemas like MISMO are going to bury, typically, the information elements that you want deep down in the structure, and referencing them in feel is going to be very inconvenient. So you'd like to map that XML to a more DMN-friendly schema like you see here. So the credit score on the left is like 9 levels deep, and it requires a filter expression. After we map it, now it's sort of right at the top and easily accessed. All right, so I mentioned in the Ignite that in addition to mapping to a more friendly schema, we probably want to prepare the data by first validating it in a process. Does the source data, which is produced, let's say, by a loan origination system, does it conform to the MISMO schema? Assuming it does it contain all of the information elements to do the underwriting decision? And if not, we will map from MISMO to PDF form, where we can add that data and try again. And if it does have all the required data, we'll map to this DMN-friendly XML, convert that to feel in the context parser, and then we can perform our underwriting decision. So we can publish this as a service, this whole process as a service. And that's this one. And hopefully this will work. So the best daily interest rate today is 4%. The loan to value, 80%. And for the MISMO XML, we want to look at this Ken customer original MISMO file. So we're just trying it from the service library. And had trouble sort of waking up the service. I might have to, looks like it's not going to work here. Hang on. I don't know if it's a latency issue or another problem. Let me bail out of this. Try to republish this. The demo gods are not with me today. So as you saw Denis do, you can just publish in one click. This will take a few more seconds than his services, and we can try that. Probably work, hopefully. Not sure if this is a network latency issue or something. It's taking a long time. Very long time. All right. Okay, so let's try it from here. So best rate of 4%, LTV 80%, and we'll put in the Ken customer MISMO file. All right, this one actually worked, and there were data errors. Remember, so that means the data was incomplete, and one of the output data elements is an error list. We can see that the data was missing a credit score and the loan amount in loan 4A1. So we have this interactive MISMO form, and we can, we need to download the PDF XML. So we said if there were data errors, we would map the MISMO to PDF XML. So we download that. Max loan from MISMO. Oops, I don't want to look at it. I want to go get it. It's in my downloads folder. And so I need to rename it from this .text file to this .xml file, and I already have that here. So I'm going to now go to this blank URLA form here and import that data. From my downloads folder, XML, this one. Okay, and now, so Ken's data has now been imported into the URLA form, and we said on 4A, we needed the loan amount. So we can put in 300,000. That was the original amount. It really doesn't matter because it's going to be overwritten. And then we need to put in his credit score 660. And we can save this as kencustomer2.pdf. And we can also export the data. So as XML, as kencustomer2 data. All right. Now, so now this exported data has all the information needed by the underwriting decision, but it's not in MISMO anymore. It's in PDF XML. So hopefully this one will work. So we've got another process, a modified process that instead of taking in MISMO, takes in the PDF XML, maps that to MISMO, and then the rest of it is the same as before. So I've published this as a service, and hopefully hasn't forgotten this one, called Max Loan from PDF. And now if we try it with the 4% best rate, 80% LTV, and now the XML file is going to be this kencustomer2 data. Try running this. This should be complete. All right. And so Ken is eligible at 80%. That's what originally we thought. And we can look at the result, and we can see that if he only borrows $272,000, the credit score needed is 660, which matches his credit score. But he's getting close. His DTI is getting close to that 36% limit for the sort of low risk. So what if he tried to borrow 81%? And when we run this, we see ineligible. So even borrowing $3,000 more, now the credit score required is 680. He's only at 660 because he's over 36%. And you could go down lower. I'm not going to do this. You could borrow only 75%. That requires a credit score of only 620, but it starts to use up, the down payment gets higher. It starts to use up all of his cash. So the point here, and I'm not going to show you how to do the mappings, the input and output parameters, because Denise showed that. It's very simple using box expressions. But what we have here is a set of artifacts that a practitioner in a bank, or consultant to a bank, a web app that the bank would put up, could use to do some of this underwriting, incorporating all of the logic of the standard underwriting rules from Fannie Mae. They could modify them with their own rules using the XML format, the standard format generated by the loan origination system, using the standard ERLA-form data to be able to correct it, et cetera. So we'll see. We're trying to make this available and make people in the mortgage industry aware that these kind of services exist, that they could be used, and we'll see where it goes. Okay, thank you for your attention to this. Any questions on this or related? Yes.
So I can see this being used to create what they used to call a pre-qualification letter to facilitate your shopping around what kind of house you can afford to buy. But couldn't you actually make it available to just anybody trying to get a sense of that? There's no data here that seems to be bound to the bank. This is all data that the person, the applicant, potential applicant, could supply just to get their own sense.
So yeah, so I mean, so if you look at the ERLA form itself, has most of the stuff is the borrower would fill out, but then there's a part of it that the lender fills out. And you could simplify some of that. Like if it's an adjustable rate mortgage, there's some tweaks that the logic needs to do. But yes, you could put this up on a website like you see on a lot of bank websites that say, you know, you put in your details of your income and your assets, and you put in your credit score. We're not even going to look it up, and we'll tell you, you know, would you qualify or how much could you borrow, et cetera. So yes, so it could be used for all these things, and the good thing is that the logic under the covers can be quite detailed and complicated. Any other questions? Okay, well, thank you very much.